All right, so here, so we have a daring 510 Newton swimmer dives off a cliff with a running horizontal lip as shown. What must her minimum speed be just as she leaves the top of the cliff so that she will miss the ledge at the bottom, which is 1.75 meter wide and 9 meters below the top of the cliff. All right, so let's see. So this is basically another, projectile problem where runner initially goes horizontally, and then obviously what we want to know, what should be the speed so that it goes and barely misses, and jumps into the water. Okay, so this time around we are given our delta y and delta x, and since we are again going down, we will take this delta y to be negative, right? So that's important. That means going down, delta y is negative. So, and also we're told that this is a 510 Newton swimmer. But here's the thing, this is one of those things where sometimes you might be given something, but you don't really need that information. And this is one of those examples. We don't really need that information at all. It just tells us, how heavy this person is. Who cares for this particular problem? It doesn't matter at all. So I remember I gave this as a exam question, one time, and I had one student who told me that she spent about 20 minutes just trying to figure out how to use this information in this problem. And obviously you don't, because the idea is that once you recognize that it's a projectile problem, you don't need any information about mass. All you want to know here is velocity,
speed.
Position, time,
and speed.
Exactly, and speed. All right, so let's see then. What we have, as you can see, right, we are told that we are launched with some velocity initial, which we don't know. We don't know that, but we know that theta initial is 0 because, it's a horizontal. All right. Now, that means, let me put here what's given to us. All right, so theta initial is 0. Then delta y is negative 9 meters. Delta x is 1.75 meters. And it seems like nothing else, but remember, it's a projectile problem. That means ay equals negative g, ax equals 0. Those are the given fixed information. All right, so what we want to find, what is this initial velocity? All right, so that's basically what we want to find in this particular example. All right, so let's see how we can solve this problem. All right, so remember what we do. We say that right away, we can say that horizontal component of this initial velocity, which we don't know, but still, it will be v initial times cosine of 0 degrees. That means equals to v initial. That means, which is important information. That means if I find the x component of the velocity or the horizontal velocity, I have the initial velocity itself. And that's what I want, right? I want the initial velocity, and now I know how to find it because this equation tells me that those two are equal to one another. So, which means that all I need to do is find horizontal velocity, and it's the same as initial velocity. Because if I then look at initial vertical velocity, which will be initial velocity times sine of 0, this is 0. And that's also a very, very important, useful information. All right, so let's go back to this first one, let me put numbers to this. So let's say this is equation 1, equation 2. These are not kinematic equations, but equation 1 and 2 for this particular problem. See, equation 2 is important because it tells me that there is no initial vertical velocity. Equation 1 is important because it tells me that what I want, which is initial velocity, is same as my horizontal velocity, and all I have to do is find my horizontal velocity. And I know one equation only where you have horizontal velocity, and that's delta x is equals to vx times time. This equation. Remember, this technically is plus 1/2 axt squared. but because ax equals 0, we can just ignore this second part because that's 0. And see, I even have my delta x. That means all I have to do is just say Vx is equals to delta x over t, and I have my Vx. And if I have my Vx, I have my V initial. But not quite, right? Because even though, yes, I have my displacement is 1.75 meters. Oops. Not 1.7 points, so 1.7. All right, so I don't have the time, right? We're not given the time. We're just given the weight, which is a useless information, then vertical displacement and the horizontal displacement and acceleration. I don't know the time. But here's the thing. This is one of those kind of two-step problems where to solve my horizontal velocity, I need to find the time. And to find the time, I need to then go to the vertical velocity, or sorry, vertical motion equation. Remember, in a vertical direction, because there's ay equals negative g acceleration.
It's negative.
Yeah, so I have this equation, right? So I have v final in the y direction equals v initial y minus gt. Equation 2, delta y equals v initial y times t minus 1/2 gt squared. Equation 3, v final y squared equals v initial y squared minus 2g delta y. Let's say those three are for now okay, enough. So I can then use these equations, and you should be able to see, right? At least equation 1 and equation 2 have time included. And your goal here is to see, let me put the fourth one too so you can see, right? Delta y equals v initial y plus v final y over 2 times time, because it also includes time. That means I have 4 different equations, and 3 out of 4 can give me time, more or less. So what you want to do here, you want to look at those equations. And you want to see, all right, so can I use equation 1 to solve for the time? Will this equation give me time? What do you guys think? From the information that I have. Okay.
Second equation.
Well, give me why this equation 1 doesn't help me here.
Because we don't know initial velocity nor final velocity.
Well, remember, this is 0, right? We just said that right there. That's 0. We technically have that.
Oh, final velocity.
Sorry, I have the wrong equation, but yeah. So we don't have, this is 0. Oh, sorry, this is we have, this is 0. But you're right, final velocity we don't have. That means equation 1 is useless to us because we have 2 unknowns. I want time, but I also have final velocity as unknown, which the same reason why this equation is ruled out, because it has time and final velocity there. So one equation that can help us is equation 2, because I have delta y, I have acceleration, initial velocity is 0, and I can then use that to solve time. That means
what about number 3?
Well, number 3 doesn't have time, so it's useless to me because I don't have this and I don't have that, and it doesn't even have time. That means right now equation 2 tells me that delta y equals v initial y times time minus 1/2 gt squared. And I can see, right, I can get rid of this term because initial vertical velocity for a horizontally launched projectile problems is 0. So this entire term is 0. And then you can see, right, all I have here is delta y equals negative 1/2 gt squared. And I can use this equation to solve for that. So let me kind of make some room over here. Okay. That means I rearrange, so then it becomes negative 1/2 gt squared equals delta y. I switch the sides. Then I multiply both sides by 2, divide both sides by g. And then what I end up with, and then also, let's say, move the negative to the other side. Well, I end up with t squared equals 2 times delta y times over g. So I kind of do it like this. I end up with it. And obviously what I do, I take the square root of both sides. Right, so once I take the square root of both sides, then I can go ahead and calculate. So this is negative 2 times delta y. Remember, delta y is then negative 9. And you need to make sure that you cancel all the negatives inside the square root. Then divide by 9.8. Then t is equals to the square root of 2 times 9 over 9.8. I get 1.36 seconds. That means we use equation 2 in a vertical direction to solve for time, and that's usually your best friend. This equation is your best friend if you want to find time in a problem like this. So I can then take it, plug in over here, then horizontal displacement of 1.75 divided by 1.36 seconds. So 1.75 divided by the 1.36 seconds, we get velocity of 1.3 meters per second, which is basically then the velocity that I want because they are exactly the same. That means we want to jump, or this person wants to jump at 1.3 meter per second in order to clear this ledge like that. Barely, so barely, but cleared.